Hello good people, I'm going to continue talking about ionic compounds. I'm going to look at the shortcut we can use to predict the ionic formula of a compound when given a metal and a non-metal. I have written three scenarios, each involving calcium as the metal and three different non-metals. In the first scenario we have a fluorine, in the second oxygen, and in the third one nitrogen. Before I look into what sort of ionic compounds I will get from these atoms, let me first determine what sort of ions I have at hand. Calcium is a metal. This means that it will donate or lose electrons. How many electrons will it lose? Based on its position in the periodic table, it will lose 2 electrons. This means that we will end up with a cation with a 2+ charge. So that is what I'm going to write for each of these calciums. A little 2+ in the superscript. What about fluorine, oxygen, and nitrogen? Each one of these are a non-metal. This means that they will accept or gain electrons. In other words, we will end up with anions. Based on its position in the periodic table, fluorine will gain 1 electron, so we will end up with a negative charge. Oxygen will gain 2 electrons, and so I will have a 2- charge. And nitrogen will gain 3 electrons, and so I will have a 3- charge. Fair enough. I have my ions ready. How will they combine? And what will the ionic formulas look like? So let me look at the first scenario. Calcium cation and fluorine anion. When writing an ionic formula, we always write the cation first. So I have calcium and then I have fluorine. But now I need to determine the ratio in which they will combine. Not all ionic compounds will combine in a 1:1 ratio. It turns out that I can use the charges of the cations to help me. The charge of the cation is 2+. I can take this 2 and place it right after the fluorine. The charge of the anion is 1-, but note that usually we do not write that 1 in, we just write in the minus. Now I'm going to write the 1 in, just to show you what is going on. So here's the 1, and this 1 will now be taken and placed after the calcium. So the ratio in which a calcium cation and a fluorine anion will combine is 1:2. It turns out that in chemistry we do not write the 1 in. Just as I did not initially have the 1 next to this minus sign, I do not need this 1 after the calcium. So this formula can be rewritten as Ca for 1 calcium and then F2 for 2 fluorine anions. Let's look at the second scenario. Now I am combining a calcium cation with an oxygen anion. As before, I start by writing the cation first, calcium in this case, and then the anion. And now I can use the crossover method again. The charge of the cation will end up after the oxygen, and the charge of the anion will end up after the calcium. So the ratio in which calcium and oxygen will combine is 2:2. This ratio can be simplified. 2:2 is same as 1:1. So I can rewrite this formula as calcium and oxygen. 1 calcium for each oxygen. What about the third scenario? Now I have a calcium cation and a nitrogen anion. I'm going to write the cation first, calcium, and nitrogen second. Using the crossover method, I can use the charge of the cation and place it after the nitrogen. And then I will take the charge of the anion and place it after the calcium. So the ratio in which calcium and nitrogen will combine is 3:2. This ratio cannot be simplified any further. So the formula will remain calcium 3, nitrogen 2. Note that in each case, I have taken the charge of the cation and placed it after the anion. And then I've taken the charge of the anion and placed it after the cation. And if the resulting ratio can be simplified, as is the case with the scenario 2, I do that as well. With that in mind, let me bring in 3 more examples. And here they are. 3 scenarios, each involving sulfur and a different metal: lithium, magnesium, and aluminium. I recommend pausing the video and determining the ionic formulas of each of these pairings. So I'm going to start first by determining what ions I am dealing with. Sulfur, based on its position in the periodic table of elements, will gain 2 electrons. This means that it will have a 2- charge. So I'm going to write that for each of my sulfurs, 2-. Lithium, based on its position, will lose an electron, so it will have a positive charge. Magnesium, based on its position, will lose 2 electrons, so it will have a 2+ charge. And finally, aluminium, based on its position in the periodic table, will lose 3 electrons and therefore have a 3+ charge. Recall that the formulas for ionic compounds are written by writing the cation first. So I will have lithium and sulfur, I will also have magnesium and sulfur, and finally I will have aluminium and sulfur. Now I need to determine the ratios in which these will combine. Lithium has a charge of +1, so that one would go after the sulfur. However, recall that we do not write the 1 in, so I'm not going to do it. Sulfur has a charge of 2-. This 2 will go after the lithium. And here's my formula: lithium 2, sulfur 1, except that I do not write in the 1. What about the second scenario? Magnesium has a charge of 2+, so I'm going to write a 2 after the sulfur. Sulfur has a charge of 2-, so I'm going to write that 2 after the magnesium. The ratio is 2:2. This can be simplified to 1:1, so the formula for the pairing of magnesium and sulfur will be Mgs. And finally, I'm going to look at aluminium and sulfur. Aluminium has a charge of 3+, therefore the 3 will go after the sulfur. Sulfur has a charge of 2-, and so the 2 will go after the aluminium. And so the ratio for aluminium and sulfur is 2:3. This ratio cannot be simplified, so I'm just going to leave it as is. In summary, when determining the ionic formulas for ionic compounds, we always write the cation first and the anion second. The ratio in which these ions combine is determined by the charge of the ions. The charge of the cation tells me how many anions I will have, and the charge of the anion tells me how many cations I need. If the resulting ratio can be simplified, that is done as well. That is all for now, and I will see you on the flip side.